Hello, class. I'm here to talk about a population proportion, the section for your chapter 8 that I promise I'll be talking about it. Also, because it's related to your homework assigned for this week, even though I really only assign the simple questions. I did not ask you to calculate, even though by now, by looking at the z distribution, the t distribution, all that, you should be in how to calculate a confidence interval. It really shouldn't be that difficult to understand it. So, might be asking yourself, how is the sample of a population any different from a population proportion? Well, think about proportion as a percentage. So let's read here that during an election year, we see articles in the newspaper that state confidence intervals in terms of proportions or percentages. Keyword. For example, a poll for a candidate that is running for president, it might show a 40% of the vote within 3 percentage points if the sample is large enough. Often, election polls are calculated with a 95% confidence. By now, you should be very used to all this. And if right here, you could have got a lot of information already. If the sample is large enough, that means a normal Z distribution with a 95% confidence. If you would refer to tables that we have used before, so a 95% confidence. Uh, if you do go to the tables, the Z table, you're gonna find a 1.96. So part of your problem would be solved already. And then it says often they are calculated with 95%. So they will be 95% confident that the true proportion of voters who favor the candidate would be between 37% and 43%. They subtract the error bound and of the proportion in this case, and they added the error bound of the proportion. Okay, so here it says the procedure to find the confidence interval, it should be more than used to it right now. The sample size, the error bound, and the confidence level for a proportion similar to that for the population mean, but the formulas are different, and that's when I wanted you to go to the summary of the formulas. But before we do that, here is a very important thing. How do we know you're dealing with a proportion problem? First, the underlying distribution is a binomial distribution. What does it mean there is a binomial distribution? There is no mention of mean or average. Moreover, remember from the beginning of the course, we did go over binomial distributions where we would see it like this, where n is the number of trials and p is the probability of success. Okay, so to form a proportion, anyway, I'm not gonna go read all this so you don't get more confused. The best thing to do is to go to your summary of formulas right here, where P is gonna be P without any right here. That's your population proportion, and this we see it a lot of times as a P hat or the little symbol. That's not the one I want to open, but let me open this one right here. If you would see a symbol, the caret, so that would be, they would call it a P hat. Okay, so that's what I'm going to be calling here. So the P hat is equals to x divided by n, where x is the number of success and n represents the sample size. Therefore, x is the number that you're looking for uh, to get the proportion, and n is the whole sample size. Um, your q, you really could think those two as p hat being your number of success and as a binomial distribution, and q hat being is your number of failures in a sample size of n. Okay, so Q is the difference between 100% minus your number of success, because you're just going to be using with that proportion to get your confidence interval, and then Q would be the number of failures, which is the difference. How would you write that down? You could tell me on a problem which distribution should use for this problem, and you say binomial. No, that would be incorrect. You have to specify. So in this case, you'll be gonna be looking at here. So you're gonna be saying this that of the normal this normal distribution is gonna be your simple, actually right here, which is the simple proportion, is actually gonna be the point estimate for the true population proportion. So it's going to be the same value as this one. And right here, you're going to do both values. Uh, that is going to be also used as an estimate. So you're going to do the P times the difference between 100% minus the P divided by the sample size and square rooted. And then you're looking at all this and thinking, I have no idea what you're talking about. Once we do the problem, it's going to make more sense, I promise. So let's go to the problem. Okay, and let me open right here. So I have assigned 66, 60, 64, 6, and 8, correct? So let's go start with 64. Suppose the marketing company did do a survey. They randomly survey 200 households, so our sample size, and they found, maybe I could make it a little bit bigger for you, no? And then I'll make it smaller. Okay. And found that in 120 of them, this is your x, right? Is your the sample size that we're trying to use um, out of the whole sample size. So that's why we're gonna have to get a proportion. The woman made the majority of the purchasing decisions. So we are interested in the population proportion of households where women make the majority of the purchasing decisions. How would I get my right here? How would I get my sample proportions? So remember, if we go up here, so you get that by x divided by n. So we're gonna do x divided by n, and that would be a 60%. And then if you do not understand, so here define the variables right here that you found, the key, the x and the p hat in words. Well, the way you could define them is that the way you can define them is that the x is the uh like say the number of success where the woman I don't want to erase makes the majority. I don't want to have to reformat it of the purchasing decisions. I can even lower that. So okay, and then we're gonna say that p hat or like this is the percentage um, of households, right? Right here, to survey 200 households. So is the percentage of households sample where the woman makes the majority. I don't want to do that. Makes the majority of the purchasing decisions. Okay, perfect. So we have defined X and we have defined P hat. Problem 66, I have assigned it to you. Uh, which distribution should you use for this problem? Well, we know it's a binomial distribution. However, I want you to put in this format right here of this formula, which I could select now. I don't know if I can. Let me see. It's not letting me just get what I want. So let me I put it over here. Okay. And then let me crop it. And that's the format that I want you to be putting. So we're gonna say p hat for this normal distribution is gonna be my, do you remember from over here? It says that the point estimate, the sample proportion serves as the point estimate for the true population proportion. So we're going to be using the same value from over here. And then we're going to do the square root. Actually, we're not going to calculate it. I'm just going to put this symbol, the square root of my P. And then the difference. What is the difference? Well, if I have 60%, so before I even, let me put 0.4 and then I'll go back. Hold on. Divided by my sample size. If you want to go over here and tell me Q, it's going to be 1 minus my 60%. It's my 40%. That's how I got this. And they both represent a point estimate for the true population. So that's how you would be answering 66. 67, you're not asked to solve it. I am going to go over it. So you can see that it's really not complicated. Now that we learned so much how to calculate the confidence interval, you should be used to it. Therefore, first, let's go over here and see for the error bound for a proportion, the error bound for proportion, what formula do they use? Well, so I'm gonna put it, I can move this. Let me move this so you can see. Okay, so for my error bound proportion, it's gonna be, well, it's asking me for my z-score. Right here, by now, you should know that these are the most common confidence levels, so you don't have to go out of your way to calculate all that. So all we have to do is a 95% confidence interval, where a 95 confidence level is going to be 1.96, and we did learn how to calculate that before. So you have 1.96, correct? Times, and then right here, I'm looking at the other portion, we have the square root of simple proportion. So right here, proportion, or you could say number of success times number of failures divided by my sample size. And that's going to be the, right here, the error bound for a proportion. And then, of course, you wouldn't be done, because if you do remember, for the confidence interval, you have to, for the lower bound, you subtract, for the upper bound, you add. So you would do equals to, and what is my actual proportion? Simple proportion, or you could call it mean. It's right here, minus my EBP. And then for the other bound, you're going to do simple proportion plus my EBP. And the reason why I have used um, the graph they provided in the problem, so you could see where all these values came from. Right here, that's your simple proportion or mean. So equals to this, your lower bound right here, and your upper bound over here. And you can see that we did calculate them correctly. If you would stay your confidence interval, you know you would have to put in 0.5. In this case, I just put 0.53. In the second one, we're going to round it up, 67. So it would be anything between 53% and 67% being the mean is going to be a 60% or you're not required, so you're just required to do 64, 66, and then for last question, 68. List two difficulties the company might have in obtaining random results if the survey was done by email. Well, I can think of quite a few problems. Actually, uh, a survey done via email. One could be first, email can be sorted as junk, therefore the person is not gonna see it. Another reason I can think is that um, recipients recipients no. Two, I can say that not every household can choose to respond, even if they see it, not necessarily they're gonna respond. I can say that not every household has an email account. Four, not every household checks, believe it or not, their email. They kind of select the ones that they want to read. And also, not every household has internet access. And we could be here and list several and several and several. Therefore, you would be done with problem number 68, which that's what I assigned for this week. And it shouldn't take a lot of time. It is a long video because I want to go over each step, but really to answer 64, 66, and 68, it should not take you a lot of time. If you do find any problems, make sure that you do email me or post the question on Blackboard, and I'll be glad to answer them. And that's all for tonight. Now we are only gonna have videos for next week.